All right, hey guys, we are going to start the practice subtracting scientific notation worksheet. Remember, you do not have to print these worksheets off. If you can look at your steps, like this top part, on the computer, and then if you want to just write the other parts down, the questions down like on a piece of paper. If you have a whiteboard, something like that, just practice doing the problems. A piece of paper may be handy so you can go back and look at it later, but you do not have to have the actual printout. All right, so we're going to skip over all of the steps because you can read those on your own. And then we're going to go ahead and get started with number 1. So this should be pretty much review. We're going to do the same thing as addition, except for today we're going to subtract. So when you have scientific notation, the first step you want to do is convert your numbers to standard form. So since this is positive, we're going to move the decimal 5 to the right. 1, 2, 3, 4, 5. Which means you have 4 blanks. So that is 550,000. Minus, remember the biggest thing when you have a whole number is that it's not 0.4. Remember, scientific notation has to be equal to or greater than 1, but less than 10. 0.4 would be too small, so you have to put your decimal to the right. It has to be a whole number, and then we're going to move it 5 spaces to the right. So 1, 2, 3, 4, 5. There's 5 blanks. Just means there's 5 zeros, so that's going to be 400,000. Remember, when you're subtracting or adding, you have to line up your place value. So ones place, tens place, hundreds place, thousands place, 10,000s place, hundreds, thousands place. Everything's lined up. And then don't forget to subtract instead of add. So 0 minus 0 is 0, 0, 0. I like to use my commas. It keeps everything lined up. 0 minus 0 is 0. 5 minus 0 is 5, and 5 minus 4 is 1. So 550,000 minus 400,000 leaves you with 150,000. The very last step that we have to do here is now rewrite this in scientific notation. So same as yesterday, you have a very large number. We're trying to first create a number between 1 and 10. 1.5 is going to be equal to or greater than 1, but less than 10. So your number in front is 1.5. Scientific notation times 10 is always next. And then you count, you moved your decimal here, but it was here because we had a whole number. So you're just going to count how many times you moved it. 1, 2, 3, 4, 5. And then the last thing you ask yourself is, should that 5 exponent be positive or should it be negative? And because 150,000 is a very large number, you're going to keep it positive. You can also think about that is if we're trying to rewrite this in standard form, this means we would move the decimal 5 right, which would create our answer. So this is your final answer written in scientific notation. All right, so just as we did with the addition worksheet, I want you to go ahead and pause this video, and I would like you to try number 2 on your own, and then I will go over it to show you if you have the same answer, but you need to, if you're just copying these down, you're not going to learn anything. So just like if we were in class, I need you to pause it, try it on your own, and then press play. All right, so this one, same thing. We have large numbers because our exponents are positive, so we're going to move this decimal 7 to the right. 1, 2, 3, 4, 5, 6, 7. Don't forget this 6 is in that loop right there, so it's already taken. You can't also put a 0 there. So there's 6 zeros. Sorry, I'm trying to make sure you guys can see as I'm writing. 1, 2, 3, 4, 5, 6 zeros. To figure out what that number is, remember you start from the right and count every 3. So there's a comma, there's a comma. So we're talking about 46 million. Minus a smaller number because your exponent is smaller. So we're going to move 6 to the right. 1, 2, 3, 4, 5, 6. There's only 4 zeros. So this number is 1,120,000. So they're going to be different lengths and numbers. So be very careful. Do not put your 1 under the 4. That's not correct place value. You have to line up your ones place with your ones place, tens, hundreds, thousands, and so on. So 0, 0, 0, 0, 2, 1, and 1. So 46 million minus 1,120,000. So we're definitely going to do some borrowing here. So make sure you follow along if that's what you're struggling with. All right, so 0 minus 0 is 0. This part's easy, 0. Now, 0 minus 2. You cannot take 0 and subtract 2 from it and get a whole number or get a positive number. So we need to borrow from what's beside it. Unfortunately, there's a 0 there, and you can't take anything from 0. 0 is nothing. So you have to come over to the 6. So you're going to borrow 1 from 6, make that 5. Now, when you borrow, it has to go, the one that you borrow from has to go directly beside it. So this 0 now becomes 10. You guys know from doing this in class, I like to do these each individual steps at a time. I don't like to do it all at once. So then I go ahead and start over. 0 minus 2, I can't do that. But now I do have a 10 here. So I can borrow from 10. That becomes 9. Sorry, it's getting a little small. Now this 0 is a 10. 10 minus 2 is 8. 9 minus 1 is 8. 5 minus 1 is 4. And bring down your 4. So 46 million minus 1,120,000 leaves you with 44,880,000. And if you think about these numbers, your answer actually makes sense. You're only subtracting 1 million of that and a little bit more, so you need a number that's pretty close to the original. All right, so this is the correct answer. However, we have to rewrite it in scientific notation. So this number is way larger than 1. So, or my bad, 10. So we need to move our decimal so that it's equal to or greater than 1, but less than 10. Our large numbers are really easy. You know, it always goes right after that first digit. And then you want to use all of your numbers that aren't 0. Just think about it. If you leave off that 8, you're leaving off 80,000. If you leave off this 8, you're leaving out 880,000. That's a lot. So you don't want to leave off either of those 8s. So you start with your number 4.488. Times 10 is always next in scientific notation. And then you just count from where you moved your decimal to where it was. It's kind of invisible here because it's a whole number. So you count 1, 2, 3, 4, 5, 6, 7. And the last thing you can ask yourself is this exponent going to say positive or is it going to be negative? And because this is a very large number, 44,880,000 is a super big number. So we're going to stay positive. Or you can think about moving this decimal 7 right, and then you would create this number. So this is your final answer. All right, once again, we're gonna do number 3. I would like you to pause this video. You try it on your own, and then we will do it together. All right, so the biggest thing about number 3, it's actually going to be very easy once you actually start subtracting it. However, if you put your decimal in the wrong place to begin with, then you're going to get your answers wrong. So remember, 7, the whole number 7 is like $7. All right, guys, sorry about that. I'm still getting used to this videoing thing. It cut out on me, but let's go ahead and get started. Number 3, like I was saying, you have to make sure you start with your decimal in the right spot. If you started with it before the 7 to the left of the 7, your answer is going to be wrong because you're going to have 1 less 0 than you need. So we're going to move it 6 spaces to the right to create our actual number. 1, 2, 3, 4, 5, 6. That's 7 million. Minus, you're going to move this one 4 to the right. 1, 2, 3, 4. Minus 50,000. Remember, do not start lining the 5 up here. You have to line up your numbers based on place value. So subtract 1's place, 10's place, 100's place, 1,000's place, 10,000's place. I said this one was going to be easy to do. It may not be the easiest one if you're not sure how to borrow, but we're going to do that now. So 0 minus 0. Zeros are easy. 0 minus 5, you cannot take 5 from 0. You have nothing. You can't take away 5, so we're going to borrow beside it. Unfortunately, you can't borrow from 0 because it has nothing, so you got to keep on going. You're going to borrow from 7 and make that a 6. Now, you can't jump over here. You have to give beside it, okay? So this 0 is going to become 10. Then you're going to start over. 0 minus 5, you can't do that, but now there's a 10 beside it that we can borrow from. So that 10 is going to become a 9. I apologize, it's kind of messy. And then your 0 becomes a 10. 10 minus 5 is 5. 9 minus nothing is 9. 6 minus nothing is 6. And if you think about your numbers, 7 million minus 50,000 is 6,950,000. If you added that 50,000 back in, you would get to your 7 million. So your answer actually makes sense. Always kind of think about that. That will help you correct any mistakes really quickly. So you have the right answer. The only thing that we have to do is write this number in scientific notation. We're going to put our decimal here. 6.95 is a number equal to or greater than 1, but less than 10. Times 10 is always next. And then our original decimal is here. You're just going to count from where you moved it. 1, 2, 3, 4, 5, 6. Last question you're going to ask yourself is this going to stay a positive exponent or is it going to be negative? You can look at it two different ways. This is a very large number. It's bigger than 1, so that needs to stay positive. Or if you were trying to convert scientific notation to your standard form, if you move your decimal 6 to the right, it would give you your answer. So you know that your answer is correct. Okay, so 1, 2, and 3, we're subtracting with positive exponents. So now we're going to move back up here to number 4, and we're going to start looking at negative exponents. You are literally going to do the same exact thing. You're going to convert your numbers into standard form. You're going to move your decimal, and then you're going to subtract. The only difference is instead of getting a very large number, like numbers in the millions, you're going to get really, really small numbers. All right, so let's go ahead and try number 4. If you want to pause this video and go ahead and try it for yourself, you're more than welcome to, but I'm going to give you one example first. All right, so negative 4 means we are going to move this 4 to the left. So 1, 2, 3, 4. Do not forget, this is the biggest part. You are moving your decimal. So it's not between the 4 and the 6 anymore. It's all the way at the front. And there's 1, 2, 3 blanks. So your new number is 0.00046. All right, same thing here. 4 left, 1, 2, 3, 4. Your decimal's now at the very front. 1, 2, 3. The biggest thing here is that you still line up your place value. The only difference is we're talking about decimals. So we're talking about tenths place, hundredths place, thousandths place. This time we have to line up our decimals from the front or the left side. So 1, 2, 3, 2, 7. So this is going to be your subtraction problem. 6 minus 7, you can't do that. So you're going to have to borrow from the 4, make that a 3. Then this becomes 16. 16 minus 7 is 9. 3 minus 2 is 1. 0 minus 0, 0 minus 0, 0 minus 0. So this is your final answer. Now we have to write it in scientific notation. So we got to create a number between 1 and 10. So we know 1.9 is going to be our number. Times 10 is always next. Now this time you're not counting all the way to the end. You're counting from where your decimal was to where it is now. So it's 1, 2, 3, 4 spaces from where it was. And now this is the biggest thing. If I'm trying to rewrite this number in standard form, I'm not going to move my decimal to the right. I need to move it to the left to get 0.00019. So I need to change my exponent to a negative. You can also think about it like your answer is super, super, super small. 0.00019 is like way less than a penny. 0.1 would be a penny's worth of money. This is much, much smaller, like teeny, teeny, tiny. So when you have teeny, tiny numbers, your exponent is going to be negative. So this is your final answer. All right, so go ahead and go to number 5. Go ahead and pause this video so you can try it on your own, but be very careful. Remember, you want to put your decimal, start with your decimal in the right spot. That's a whole number 8. All right, so go ahead, pause this, and try it on your own. so you want to move your decimal 5 left. 1, 2, 3, 4, 5. Remember, now your decimal is where you are moving it to. The reason we're doing these jumps is to move the decimal. So now we stopped at the front to all the way to the left. Your decimal's here. This one is not there anymore. All right, and this is also taking up a spot, so you don't have 5 zeros. You have 1, 2, 3, 4 zeros. So your first number is 0.00008 minus, this time we're going to move our decimal 6 to the left. 1, 2, 3, 4, 5, 6. So you have 5 zeros in front, 7 and 3. Be very careful that all of your place value is lined up. Now, you do need, for subtraction, for adding, you don't really need values here. You know it's 0, but for subtracting, you are going to have to borrow. So make sure you put those zeros there. So 0 minus 3, we know we can't do that, so we need to borrow. Unfortunately, we can't borrow from 0 because it has nothing to give you, so you got to borrow from the 8. So that 8 becomes a 7, this 0 becomes a 10. Now, you know I like to do this in 2 steps. So now we can take 0 minus 3. You can't do that, but there is a 10 beside it to borrow from. So now that becomes a 9, this 0 becomes a 10. 10 minus 3 is 7. 9 minus 7 is 2. 7 minus nothing is 7. And be very careful here that you bring down the correct number of zeros. If your numbers are even slightly off, then sometimes you get an extra 0 in here. So your final answer is 0.0000727. If you get that answer, you're right. The only thing that you have to do is rewrite it in scientific notation. So you know we need a number equal to or bigger than 1, but less than 10. So our first number is 7.27. You know, scientific notation always has times 10 next. And then you're going to count from where the decimal was to where it is now. 1, 2, 3, 4, 5. However, if I move this decimal 5 right, it is not going to create this answer. I need to move it 5 to the left to create this really, 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 really small number. So I need to make sure that I make my exponent negative. Because 0.000727 is a teeny, 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 tiny number. All right, last one. Go ahead, pause this video, and I want you to try number 6 on your own. It is the last one that we are doing today. All right, you are subtracting 2 numbers written in scientific notation, and they both are whole numbers. So you got to make sure that you started with your decimal in the correct space. If you didn't, your answer is going to be wrong. You can't just add a 0 or change something. It's going to make it different. So make sure you're putting your decimals in the right spot to begin with. You're moving this one 6 left. 1, 2, 3, 4, 5, 6. Now your decimal is all the way in front. That means you're going to have 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros and a 9. Minus this one, you're going to move 8 left. 1, 2, 3, 4, 5, 6, 7, 8. Be careful, count slowly. 1, 2, 3, 4, 5, 6, 7. And make sure if you have 8 zeros and you also had 1 space with the 5, then you have too many, okay? So some of you do this a little fast and you just lose track. So make sure you're doing it slow enough that you don't make mistakes. So you have 7 zeros. Make sure they line up. 1, 2, 3, 4, 5, 6, 7, and then 5. Just like the last one, you need to make sure that you put your zeros here because you have to have something to take away from. Same sort of borrowing. You should be getting very good with your borrowing now. 0 minus 5, you can't do that. So you have to borrow from the 0. Unfortunately, you can't take anything away from nothing, so you got to borrow from 9. If you take 1 away from 9, it becomes 8. This 0 becomes 10. Then from doing this for so many days with me, you know that I like to do in 2 steps. So now let's start over. 0 minus 5, you can't do that. So you have to borrow from 10. If you take 1 from 10, it becomes 9. Add it to this 0, becomes 10. 10 minus 5 is 5. 9 minus nothing is 9. 8 minus nothing is 8. Here, just make sure you have the correct number of zeros. So this number is the tiniest of them all that we've done today, 0.0000895. So that's your final answer. Last but not least, we have to write in scientific notation. You need a number less than 10, but greater than or equal to 1. So your first number is going to be 8.95. Times 10 is always next. And then you're going to count from decimal to decimal. 1, 2, 3, 4, 5, 6. The only problem here is if we move this decimal 6 to the right, it'd be an incredibly large number. We need a small number. So we're going to have to change this to a negative because this is a teeny tiny number. And if we were trying to convert this to this number, we would have to move our decimal 6 left. All right, so this is your final answer. We are done for the day. I would keep this if you have this paper somewhere. These are 6th grade examples. Tomorrow you're going to have a quizzes that you're going to do. It's 8 problems. I believe there's 5 that have positive exponents and 3 that have negative exponents. You're going to do the same exact thing. You have unlimited tries on that. So if you don't like your first score, you're more than welcome to do it again. Make sure you're actually doing the problems and not just guessing, because your quizzes are going to be graded. So just make sure that you're trying and doing the best that you can. If you have any questions, you're always able to email me or message me via Remind. So yes, reach out if you need anything. I hope you're all doing great, and hopefully we'll see you soon.